Hi, future doctors. Welcome to the next class. In this class, we will discuss about Ohm's law, different forms of Ohm's law. So, whenever we are connecting for a conductor voltage, exactly what Ohm said, we will see. For a bulb means within this filament will be the filament is nothing but conductor. So, if you supply 10 volts voltage, 20 volts, 50 volts. So, for which voltage this bulb is going to be getting more amount of current. So if you increase the voltage, the amount of current passing through this bulb also increases. So that one also means ohm set. This one we can also say, but ohm set first. Therefore, we are calling this one as Ohm's law. Voltage is always directly proportional to current because charge is going to be shifted. The amount of work done to bring the charge in electrical energy case, we are going to get V is equal to W by Q. W is equal to QV. So I is equal to here Q by Q. Therefore Q is equal to VIT we will say. This is nothing but electrical energy equation we will be saying. So now according to Ohm's law, V is directly proportional to I. So we will write one constant. That constant only we are saying it as R. So what is R here means here resistance of this conductor. R is nothing but resistance. Resistance of the conductor. What is the unit for resistance? V by I. Volt per ampere. This one only they will say ohms. Ohms is the unit of resistance. Next, what is the reciprocal of resistance? So G is equal to 1 by R. What is the reciprocal of resistance means? This is nothing but conductance. Conductance, resistance. The tense will be the reciprocal. Some people will get confused. Without getting confusion, we can remember like this. Tense, resistance, conductance. Now, what is the unit of conductance? Ohm reverse. We have to means ohm inverse. So ohm inverse can be written as mho. Mho is the unit. Now they will ask dimensional formula. What is the dimensional formula means? For voltage, V is equal to here. It is there. What is voltage here? V is equal to W by Q. So W by Q. Once you wrote this, work done. M L square T power minus 2. Charge. AT current A. So M L square T power minus 3 A power minus 2. So this is the dimension formula for resistance. Conductance means you have to reverse this. Once you reverse M power minus 1, L power minus 2, T cube A square you are going to get. This is nothing but conductance. Okay, resistance, conductance. Now, this resistance depends on what factors? See here. Conductor, if you are taking like this, length and area. So, resistance is always directly proportional to length, and the resistance is inversely proportional to area of cross section. So, if you are taking three conductors like this, which is having more resistance means third one. So, inversely proportional to area. So, if you are increasing the area, resistance is going to decrease. If you combine both, R is directly proportional to L by A. So we will write one constant. That constant only we will say rho. So rho L by A. So what is this rho means? Rho is nothing but resistivity. Resistivity or specific resistance. So what are the units for rho and dimensional form? Rho is equal to RA by M. So ohm meter square per meter. So that is nothing but ohm meter. So ohm meter is the unit for resistivity or specific resistance. Just already we wrote dimension formula for ohm. So for this we have to add one L. Then you will get dimension formula for resistivity. Now reciprocal of resistivity, that is nothing but conductivity. Sigma is equal to 1 by rho. Okay, sigma equal to 1 by rho. The sigma we are calling it as conductivity. Conductivity. So this is reciprocal of resistivity. I told you na, VT, there you will get 10 stems. Sigma equal to 1 by rho. So units for this, ohm inverse, meter inverse. Otherwise, mho, meter inverse. And for this conductance also, ohm inverse, mho they are going to say. Some people will use Simon also. So all are going to be same thing. So this is about conductor. This is about resistance of the conductor. R is equal to rho L by A. And different forms of Ohm's law. So we came to know V is equal to IR. So I into. Now only we wrote capital R is nothing but resistance is nothing but rho L by A. And relation between electric field, voltage and length. V L E relation. What you will be getting here? E is equal to V by L. Therefore, V is equal to EL. So therefore, if L gets cancelled, E is equal to I into rho by A. So what is I by A we came to know? I by A is nothing but J. So E is equal to rho J. So this is the relation between electric field, conductivity and current density. E equal to rho J, rho J. If you remember rho J, you will get it. Isn't it? E is equal to rho J. This is also Ohm's law. Next, J is equal to E by rho. So what is 1 by rho we said? Reciprocal of resistivity is a conductor. So J is equal to sigma E. So V is equal to IR, E is equal to rho J, and J is equal to sigma E. So all these are different forms of Ohm's law. Very important relations. Different forms of Ohm's law. These three equations. So you should remember carefully. Okay. Next. So the conductors which obeys Ohm's law, those are called ohmic conductors. The conductors which obey Ohm's law, ohmic conductors. So which does not obey Ohm's law? Non-ohmic conductor. Non-ohmic conductor does not obey. All metals will be coming under ohmic conductors. All semiconductor devices and transistors, those will be PN junction diode, all these will be coming under non-ohmic conductors. The graph drawn between voltage and current will be the straight line because directly proportional straight line passing through the origin for ohmic conductor. For non-ohmic conductors, graph is going to be curve. It is not a straight line. So not a straight line, non-linear graph you will be getting. Now what is the slope of voltage and current graph is going to give? So many times we discussed if theta is given, in basics also we give. Slope is going to be given change in y-axis by change in x-axis, otherwise y-axis by x-axis. So what is V by I we said? So V by I we said resistance. R is equal to V by I. So slope of voltage current graph gives resistance, like that you can remember. They will give theta. So let us assume, so V and I graph they will give. So they give two graphs for you. So one is with 30 degrees, one is with 60 degrees, A and B. So find the resistance of A and B they will have. So resistance of A is tan 30, resistance of B is tan 60. If they reverse this, I and V they give, you will get reciprocal of resistance. That is nothing but conductance you will get. Next, dependence of resistance. So how resistance is going to be dependent? So R is equal to, we got rho L by A. So if length is going to be doubled, they will say. Length is going to be doubled. What happens to resistance? Whenever length is increasing, its area is also changes. Area is also changing. It will not be same. Therefore, we have to keep initial volume, final volume constant. So R is equal to rho L by A. To get volume constant, multiply and divide with L. So R is equal to rho L square by area into length gives volume. Now, if we increase length also, L to 2L, its volume is constant. Therefore, R is directly proportional to L square. Isn't it? Like that, if we are taking area is going to be changed. At that time, you should multiply and divide with area. Length into area gives volume. R is equal to rho V by A square. Now, R is inversely proportional to A square. If area, if you are taking pi r square whole square, therefore inversely proportional to R power 4. So resistance is directly proportional to L square, inversely proportional to A square, inversely proportional to R power 4. This is how resistance is going to be varied with conductor. And variation of resistance with temperature. If temperature increases, what happens to resistance means resistance also increases for conductors. For semiconductors, it is going to be reverse. For semiconductors, it is going to be decreases. Variation of resistance with temperature. RT is equal to R naught into 1 plus alpha T they are going to. Like coefficient of linear expansion in first year. Alpha is equal to L2 minus L1 by L1 into T2 minus T1. Same like this, you will write this equation. Where alpha is nothing but temperature coefficient of resistance. So this is how resistance is going to be varied with this equation. How they may ask problems from this, we will discuss in our next class. Okay, thank you.